Hi and Assalamualaikum. My name is Norazila binti Muhammad Lizam. My matrix number 01DKA19F2022.
Hi, my name is Nur Adibah binti Yuzaili. My matrix number is 01DKA19F2061.
Assalamualaikum and hi, my name is Nor Kalisha binti Muhammad Fairuz, matric number 01 DKA 19F2059, and we are from DKA 3A. Let's start with introduction. Traversing is a type of control survey that involves the construction of a set of stations connected by angles and distance. Distance and angles can be measured using the total station. Among the work are to measure the general survey angle, preparation of control survey, contour and detail mapping, as well as setting out as contraction work. Use of total station in traversing work is to make the process of computing and modification of traverse as well as traverse design. Moreover, the application of coordinates for points is very useful in civil engineering projects.
And for today, I will present about types of traverse. The first type is closed traverse. It can be identified if the line forming the circuit will end at the starting point. The second type is open traverse. This is when the line that forms the circuit ends somewhere else and not at the starting point. And the last type is link traverse. Link traverse is the type of traverse where an open type traverse is joined at the end of the existing traverse to produce a closed loop or closed traverse in a link traverse.
The objective of traversing work is to create a network or structure of traverse leg and traverse station, to determine the nature of error affecting the traverse work, to compute coordinate for traversing, to produce topographic maps of the survey area for a variety of purposes, and to carry out the temporary adjustment of a total station.
Next, I will present about the equipment that used in traverse work. The first equipment is theodolite. It is a precision instrument for measuring angle in the horizontal and vertical planes, and it also used mainly for surveying application and have been adapted for specialized purpose in field like meteorology and rocket launch technology. Okay, let's continue with the second equipment. The second equipment is tripod. The main function for tripod is to ensure a stable instrument setup for reliable measurement. The leg can be adjusted to get the vertical height that required. Tripod must be set up again, loosen the screw, and adjust again once the instrument moves. It is also to make sure the level tripod placed horizontally. The third equipment is prism. Prism are surveying tools used with EBM and total station to reflect the transmitted signal. Prism must be tri-bridge mounted if the higher level of accuracy is required. Prism mounted on adjustable length. Prism poles are portable and suit particularly. The last tools or equipment is prism pole. Prism pole can be used to measure the elevation of a specific ground point by using a side level, which is it is very important if you want to get an accurate result.
Next, we have fieldwork procedure. Step 1. Tripod was erected in middle of the picket that was planted. Step 2. Theodolite is attached on the tripod. Step 3. Tripod legs are embedded in the ground while keeping the picket center. Next is step 4, which is the picket is seen again through the lens on the theodolite to make sure it's located in the center. Step 5. Circular bubble is adjusted until it enters the circle by adjusting the tripod legs. And 6. Vertical bubble that present on the theodolite tool is adjusted until it center. Step 7. Vertical bubble is checked from all sides. And 8. picket and vertical bubble are checked again to make sure it's center and stable. We're going next to the measuring data procedure. Step 1. Total station instrument has two phases, which is phase left and phase right. Step 2. Starting from the phase left, target the prism at back to get a setback bearing reading, which is 124 degrees to 23 minutes and 45 seconds. Step 3. Press the button to get the angle set by entering the bearing value, and we will get the measure distance, which is 14.088 meter with the angle set of 89 degrees 43 minutes and 30 seconds. Step 4. Turn the total station in a clockwise to target the prism at the 4th station and get the reading for the 4 bearing, which is 155 degrees 20 minutes 30 seconds. Step 5. Press the button to get the measure distance, and we get 13.811 meter. Step 6. Change the total station face to the right and target to the prism at back station to get a back bearing for the 4 right is 304 degree 23 minutes 45 seconds. Next, step 7. Press the button to get the angle set by entering the bearing value, and we will obtain the measure distance 14.088 meter and the angle set 270 degree 60 minutes 40 seconds. Step 8. Turn the total station in a clockwise to the target prism at the 4th station and get the reading for bearing for face right is 335 degree 20 minutes and 40 seconds. Last but not least, step 9. Press the button to get a measure distance, and we get 13.810 meter.
I will present about data collection. Based on this diagram, we can know the type of traverse that is closed traverse. We can also obtain points in traverse work as well as bearing and distance. This is the data that has been collected based on the previous picture. There are 4 lines in this work: line UT, TS, SV, and VU. We also have collected data for the distance and bearing for each line. Analysis and data calculation. For data analysis and calculation, we need to calculate the departure and latitude values first. To calculate it, the distance sin theta formula is used for departure, while distance cos theta is used to find latitude. Theta in this formula refer to bearing value. In fact, we need to do it to get the departure and latitude value for each line. Then, add all the departure and latitude value for each line to get the sum of departure ED and sum of latitude EL values. After identify the value of latitude and departure, we can calculate the E-closure. For E-closure, we use the formula square root EL square plus ED square and enter the value of ED and EL, that is sum of departure ED and sum of latitude EL that we have added for each line, which is 0.0898 for ED and negative 0.085 for EL. Then we will obtain a value of 0.124 meter for the E-closure. After calculate the E-closure, we can calculate the precision, that is precision equal to E-closure over perimeter, and we will obtain the value 8.3941 times 10 power of negative 5 for precision. This balancing of latitude and departure is done when the latitude and departure values cannot be zero. To calculate the balancing for latitude and departure, we need to identify the correction value for each line on latitude and departure first. To calculate the correction, the formula for calculating the correction in latitude is correction in latitude AB over EL times latitude AB over perimeter. For example, correction in latitude for line UT equal to negative 0.085, which is the value of some latitude times 364.55, which is the value of distance for line UT, over 1477.23 is the value of perimeter, and we will get the answer negative 0.0210. To calculate the departure correction, use the formula correction in departure AB over ED times departure AB over perimeter. For example, correction in departure line UT equal to 0.0898, which is the value for sum of departure, times with 364.55, which is the value of distance for line UT, over 1477.23, and we will get the answer 0.0222 for correction departure in line UT. This estimate will be done on each line to find a correction for latitude and departure. Then, add all the correction on the each line to get the value for sum of latitude and sum of departure. To calculate the balance for latitude and departure, we will use the formula balance latitude equal to latitude minus correction latitude, while for the balance for departure is equal to departure minus departure correction. For example, the balance latitude for line UT is equal to negative 72.2258 minus negative 0.0210. So, we get the answer negative 72.205, while the balance for departure is equal to negative 357.3236 minus 0.0222. And the answer is negative 357.3458. So, after we calculate the value of balance latitude and departure for each line, we will add a value for each line, and we will get a value of 0 for balance latitude and departure.
And now, let's continue with the last content for this video. It is a conclusion. Balancing for latitude and departure in traverse is to obtain a more likely value for the location of the corner for the traverse. Bowditch is the most popular method for balancing error. Bowditch rule created by Nathaniel Bowditch, who is a surveyor, navigator, and mathematician. This Bowditch rule method is used when angles and distance have some error. Error that accidental and the sum of departure and latitude value cannot be zero. To calculate the balancing for latitude and also departure, we must identify the value of latitude and departure first, then get the correction value for latitude and departure. Using the formula balance latitude divide departure equal latitude divide departure minus correlatitude divide departure. Insert the value of the latitude or departure value that has been identified. Then, subtract with the correction value that has been calculated. After making the subtraction, we will find the balance value for latitude and departure. This method is performed on each line. Then, add all the value for balance latitude and departure, and we will get the value of 0.
Thank you for watching.